Welcome to Maths and Science by IITian channel. This lecture is the second lecture in dimensional analysis of the physics part 1 for IIT JEE and NEET examinations. In the first example, first lecture on dimensions, we have seen the quantum physics example involving Planck constant and other parameters. In this lecture, what we have to see is that we have to find out with dimensional analysis what is the left hand side, that is μ₀ into ni by 2 into s into vector phi. This is what we have to find out, where μ₀ is the permeability of a free space, n is the number of turns per unit length of a long solenoid, I is the current, and s is the radial distance from the axis. A long solenoid is there with n turns per unit length, carrying a current of I, and where μ₀ is the permeability of free space and s is the radial distance from the axis, what this particular equation denotes to be understood from the dimensional analysis, not from the knowledge what we have got. From dimensional analysis, we will try to find out what this equation means. Let's go further. The equation is like this: μ₀ ni by 2 into s into phi cap. This is the vector. Because phi cap is the unit vector, it is called as azimuthal unit vector. Is unit vector, that is azimuthal unit vector. It is no dimensions. A unit vector does not have any dimensions. It is dimensionless. Azimuthal unit vector has no dimensions. It's a unit vector. Now here μ₀ is equal to permeability. Permeability of free space. Let us analyze on the left hand side as in the lecture 1 of dimension 1, where we have explained about the Planck constant. Let us analyze one by one what is on the left hand side. μ₀ is equal to permeability. What are the permeability units? μ₀ has the units kg meter per second square per ampere square. You treat it as a homework for you to check from the standard textbooks about the permeability units. μ₀ is equal, this is the unit of μ₀. Then number of turns, n is equal to number of turns per unit length. Number does not have any dimension, hence it has a dimension of 1 by L per unit length, that is meter to the power of -1. We are finding the units first from the dimensions. From the dimensions we are finding the units. From units we try to arrive what that particular equation. This equation means μ₀ni by 2 into s into unit vector phi. Now, what is I? I is equal to current in ampere. That is equal to a to the power of 1. Then what is S? S is equal to radial distance from axis. Any distance is equal to L. That is equal to meter. Now, we will combine all these. What ultimately? μ₀ni by 2, μ₀ni, n here it is given as a small n, I by 2 into s phi cap. μ₀ is kg meter per second square per ampere square, kg meter per second square per ampere square. N is number of turns per length, that is meter per meter. I is ampere divided by 2. 2 does not have any dimensions. And S is radial distance L. That is meter. When you combine all these things, this meter, per meter and meter goes off. This ampere goes off. Here 1 ampere is left over. Per second square it will be like that. This meter will be same. The final dimension is kg meter second square into a to the power of -1 by 2. 2 will not have any bearing. Hence, we can try to say by neglecting the constant, the units will be kg meter per second square per ampere. What is kg meter per second square per ampere? Is nothing but Tesla meter, TM. kg per second square per ampere into meter. That is equal to Tesla meter. This is the unit of, what is the Tesla meter? Tesla meter is the unit of vector potential. That means once you know the basic units of Tesla and once you know the basic units of μ₀, then only you will be able to understand and derive this equation μ₀ni by 2 s into phi cap. Therefore, μ₀ ni by 2 into s phi cap is equal to vector potential. In electricity and magnetism, it is given by vector A by a symbol that is equal to Tesla meter. The unit is Tesla meter. This is the answer for this. Here you please understand one thing. In the previous example also, by knowing simply what is a Planck's constant is not going to work. The Planck's constant is combined with energy, mass in dimensions 1 lecture. That we got a dimensionless quantity. Here we got a quantity with dimensions which is called as the vector potential. Vector potential is derived from the concepts of permeability and also radial distance, number of turns per length and current, and we got ultimately the dimensions of vector potential. In this, what are the things to be known to us, even though they are known individually? When you can combine the different quantities in physics, we will arrive a new quantity. In this example, what are the quantities? We have got one is vector potential as the ultimate answer. Second is permeability. μ₀ in free space. Number of turns per unit length. That is n. And current in ampere A. This is in Tesla meter. Fifth one, radial distance. L. When you know all these 5 units and dimensions perfectly, then only you can solve the example which I have given you. With this, I want to stop this video. Thank you for listening to me. If this video has provided any value addition to your knowledge, please subscribe to my channel. Maths and Science by IITian. Please make sure that just by knowing the dimensions or constants of certain things, we cannot answer the questions in the NEET exam or IIT JEE exam or advanced examination unless we know the application of them. I am making you prepare for the applications of the knowledge you have already got, so that I will be solving this type of advanced level questions, so that you will get a repetition of the knowledge and application of the knowledge on the ground in the examination hall, so that you can do better. Try to do better, acquire the knowledge, and try to apply the knowledge so that you can do better. Definitely application of the knowledge is going to help you. And that's what I am trying to help you in the application of the already acquired knowledge. Best of luck to all of you. Thank you for listening to me. Thank you for viewing my lecture. Please subscribe to my channel.